Saxon's Trig lesson 68, part D. I wanted to do about deriving the formula I wanted to do this in another video so that I could go ahead and write this out. So let me stop and explain why we have the things that we have. So the vertex is going to be at 0, 0. The focus point, is going to be at 0 and some unknown location. We're just going to call it P. So I have in my graph my vertex point at 0, 0. I've put a dot somewhere on the axis in the opening for the focus point, and I've labeled that point 0P just as I had it here. And then the directrix line will be the y equals negative P. And so I know that according to the focus definition, this line and this line are supposed to be the same length. Now the way they're drawn, this one looks longer than this one, but don't worry about that part. I've not drawn this stuff to scale, but we are trying to prove that this distance matches this distance. And what happens, like what formula do I get when I do that? All right, so now that we've labeled this, and then I called this one XY because I'm randomly sticking a spot somewhere on the parabola. And then you see here that the directrix dot matches the same X, and it's the opposite of how far up this one was should match how far down this one is, therefore it's negative P. Okay, so let's do the distance formula from XY to 0P. So we know that that distance formula is in a large square root. Our x's subtract and are squared. Our y's subtract and are squared. So that will be x minus 0. And this one will be y minus p. And I'm sorry, I don't have enough room because I'm running into the graph here. But this should equal the same distance of this one to this one. Again, I will have my x's squared, my y's squared. So this will be x minus x, and this will be y minus a negative p, changes it to positive p, and it's squared. So now I will work this out. So x minus 0 is just x, so x squared plus, and this one I'm doing my shortcut, so y times y is y squared. Y times negative p is negative yp, but I have two of them because I always double it. And then negative p times negative p is positive p squared equals x minus x is 0. 0 squared is 0, so I don't really need it. 0 plus something isn't going to change it. So all I need to do is FOIL this one out. Y times y is y squared. Y times p doubled to 2yp, and p times p squared. Now, why did I not write the square roots around both? Because my very next step would be to square both sides and kill off the square roots, so I just ignored them. Now, I don't have a matching x squared on this other side, but my y squareds will cancel each other off. You know what? Let's move this down a bit. X squared. All right, minus 2yp has a matching 2yp over here. So let's add this so that on the other side I get 4yp, and the p squareds cancel each other off. That moved that one. Okay, so that's all the parts. So now if I solve for the y, I get y equals, I'm going to do it exactly as they have it and then fix it, I think. So the x squared is up here, and I'm dividing by 4p to separate it from the y. Now, to make this match what I want it looking like, the equation that we know we're headed to, y equals, and instead of writing the x squared in the numerator, I'm writing it off to the side. So what is the placeholder for the top of that if I slide that to the side? It's a 1 to placehold it over, oh look, that's the formula, and that's where they got it, 1 over 4p, and that's the deriving of how they got to that formula for parabolas.